working on your delta math. But the compound interest formula, there's kind of two types of problem you're going to see in these different sections. One is if your interest is compounded daily, monthly, quarterly, or annually. What that means, if you don't know what this compounded word, basically that's how often they're going to look at what money you have and give you interest on it. So they might like apply interest once a year. They might apply it every day, and like the night, if you actually are investing money, you want them to do you want them to apply interest as much as they can, because obviously as you get more and more, if you're gaining interest on something, if they're like, you'll gain more interest on the interest. So like if you're like saving money, it's definitely in your interest to have them compounded as much as possible. So one kind of a couple notes here. First off, daily, that means it happens obviously 365 times a year. I mean, I know leap year is technically 366, but we'll just do the standard 365. Monthly would be obviously 12 times a year. Quarterly would be 4 times a year. Annually means once a year. There's some other ones you could see. You could see semi-annually, that means twice a year. If you see, so there's other ones they could use, but these are the ones you should see in Delta Math. But just keep in mind, there might be some other words that mean different amounts for each year. In this formula, A is your final amount, like how much money you would have after investing for a certain period of time. Oops. P is called your it's like your initial amount, or it's your principal. Basically, how much money do you start with? Like if you're investing, how much money do you first put in? That's what your initial principal. Is it spelled like that, or is it principal spelled the other way? Let me see. No, that is how you do it. Okay, because isn't there like principal with like PLE? I don't know what the difference, but this is how this is according to Google. This is what Google said. I'll go with it. R is your interest rate. N is how many times. See how I worded this? It's the number of times. I'm sorry, I know my chicken scratch, but it's the number of times interest is applied. In a year. And just to kind of maybe clear, like these, like when I refer, these are like the end values, if that makes sense. So like if they said they're compounding your daily, like your interest daily, your end would be 365. If they said that your interest was being compounded monthly, your end would be 12. So your end's going to change based on these words. And then T, finally, T is just the number of years. And you're going to see some of the problems we're looking at today, they're going to say it's compounded daily, monthly, quarterly, or annually. If that's the case, we're going to be using this formula here. Sometimes they're going to say your interest is compounded continuously. What that means is that they're always calculating interest. Instead of doing it a set amount of times per year, it's like always being calculated throughout the year. Like every second, every hour, it's being, your interest is being calculated. If it's compounded continuously, you're going to use this formula here with that variable E, or that constant E, which remember is a model of continuous growth. So anytime you see compounded continuously, you're going to use this formula with the E in it, or Euler's number. So one other thing before we kind of jump into some examples, when you plug in your interest rate, you need to make sure it's in decimal form. So remember, the change of percent to a decimal, just divide it by 100, or just move the decimal place to the left twice. But just make sure when you're plugging in your interest rate, don't put, if it's 10%, don't put 10 in, you would do 0.10. Like, so you need to just make sure your percents are in decimal form. But let's just jump in. So you're going to see there's 5 sections. You're going to see 5 different sections. Basically, you're going to be solving for different variables in these formulas. So this first problem, it says Nathaniel invested $2,900. So that's like, I like to kind of label some of the variables. That's his principal. That's what he's starting with. So that's a P. I'm labeling that. He pays an interest rate of 5.4%. So that's the R. compounded continuously. So since it's continuously, we're going to be using this formula here. And then it says, assuming no deposits or withdrawals are made, how much money to the nearest cent would be in the account after 11 years? So that's the T. So we're really, if you look at what we have, I mean, remember, E is not a variable. Remember, E is like a constant or a value, like it's approximately 2.7. So remember, E is not a variable. So in this formula, so we have everything except A, if you kind of look. So this first section is pretty simple. Basically, you're just going to kind of plug and chug. So it's going to be 2,900 times E, and then our R, like I said, remember, you want to change this to a decimal. So either move the decimal place to the left twice or divide by 100. So 5.4% would be 0.054 is a decimal. So it'd be 0.054 times 11 years. Sorry, I know this is a little sloppy. So then you're just going to put this in a calculator. Let me just write this down so I don't. So I'll just switch to my calculator here. So to type this in, you're going to do the principal, so 2,900 times, to do E, you see above the LN button in blue, I don't know how well you can see it here, but if you do second LN, you'll see it'll do E, and then you would just do 0.054 times 11. If you're on an actual graphing calculator, I'm not 100% sure, but you probably want to put this in parentheses just to make sure that it knows that whole thing is the exponent. Sometimes calculators might get messed up. This app definitely wouldn't have an issue with that. But if you plug it in, it's approximately 5,252, and they wanted us to round it to the nearest cent. So the nearest cent, it would just stay as 53 cents. It wouldn't round up. It's 534, so the 4 doesn't round up. So that would just be your answer. Okay, so this first section should be pretty straightforward. I mean, you're basically just going to get your variables, plug it in, even if it's one of the other sections, which maybe we'll have to look at because this continuous compound formula is a little bit simpler to plug in than the other one sometimes. But let's look at our next section. So this one, it says we're going to be solving for time, but it says Kaylee invested $130. That's compounded monthly. So since it's compounded monthly, we're going to use this top formula. So I'm just going to rewrite the formula just so we got it handy, but we're going to use the A equals our principal. Oops, my wrist, but it'd be 1 plus R over N up to the NT power. So if we look, 830 is going to be your principal. That's how much you put in. Our interest rate, I'm just going to change that to decimal form. So that would be 0.066. Ooh. Okay. Compounded monthly. So remember, that's how often it's compounded is your N value. So since it's monthly, how many times would that be in a year? Well, 12. So that's your N value. So our N is 12. And blah, 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 assuming no withdrawals or anything like that, no nonsense. How many years would it take to reach 1,260? So that's going to be the final amount, or like your new amount. That's our goal. So if we just kind of plug this in, we're going to have 1,260. I might actually, I'm going to write this over here. I'm trying not to write like a child. So if we plug everything in, we'd have 1,260 equals 830. 1 plus 0.066 all over 12. And then we would have 12t as our power. And we're trying to solve for that t variable. How many years would we be investing for this to happen? So we want to start solving for this exponent. So the first thing we want to do is clean up anything we want to get like what's raised to our power by itself. So we would divide the 830 over. And we're just going to put this in our calculator. So 1260 divided by 830. Okay, and one thing to note in this problem, we're rounding to the nearest year. So that makes me not as worried. One thing you want to be careful, you don't want to round too much because I get kind of nervous that maybe I'll get the wrong answer because of it. But since we're rounding to the nearest year, that makes me not too much worried because it's probably not going to be super, super close. So like between years, you know what I mean? So I'm going to put 518. I'm going to put 3 places just to be safe though, because I always get a little bit nervous. And I'm just going to go ahead. I'm going to simplify the inside of my parentheses. You don't have to do this, but I'm just going to figure out what 1 plus 0.066 over 12 would be. So I just plugged that in. I got 1.0055. You don't have to do that, but I prefer to have it rid of it. So what we're going to do to remember to kind of solve for something in a variable, you can take the log of both sides. And maybe I'll use a different color. And honestly, we'll see. It looks like this might take longer than I planned. So I might even get, like, I can give you guys some time on Thursday to work on these if you want. Like, I'm not trying to rush, but and remember, when you take a log, remember your exponent, you can move in front. So really I could keep this log 1.518, but I can move that 12t like to be in front of this one. So then to solve for t, basically I would just have to divide everything that's on the same side as t. So basically you're going to divide the 12 over, and you're going to divide that log part over. Because that would basically get rid of this 12 and this log. I'm kind of skipping a little bit of writing. But basically, we're going to put this in our calculator. Here, I'm going to just write this down. Log of 1.518 all over 12 log of 1.055. Let's go to our calculator. And you would do log of 1.518 divided by, I'm kind of worried, hopefully it doesn't screw up, we'll see. I'm going to just put parentheses. I just get worried that it won't realize that I wanted to divide it by all of this. .055. And it's approximately 0.649. So, and they wanted the nearest year, so it would be 1 year. So you got 1.099. Here, let me see how I plug. I'm kind of worried how I plug this in. One thing you could do is just do the log part and then divide it by 12 separately. Maybe how I'm typing it in is. Oh, did I do? Oh, okay. So maybe I screwed up something. Okay. Oh, there's 2 zeros. That's why. Okay, I see what you're saying. So I'm just going to divide the log part first. So it'd be 1.0055. That would make a difference. And then I'm going to divide that by 12. Oh, so it's about 6.3. Let me see. I'm kind of worried if you put it in all at once. Maybe I'm just kind of nervous that maybe it's not realized. Let me see if that matters. Sometimes you got to be really careful with parentheses because it might think you're dividing by 12 and then multiplying by this. If you type, I don't know if you type it like what I got in right now, Kamari. Yeah, because see how I type this is wrong. But you want to make sure if you're trying to put it in all at once, you got to put parentheses, because if you don't, like if you don't put extra parentheses, it's going to think you're dividing by 12 and then multiplying by that log. So maybe an easier way to do this is like when you're, I was just trying to skip a little bit of steps, but it should be the 6.3. So the nearest year would be 6 years because they want us to round. But I try to just skip a step. But honestly, when you put this in your calculator, you might be better off just dividing one of these at a time. Like just do log of 1.518 divided by 12, get that answer, then divide it by the log, or divide it by the log and then divide by the 12, if that makes sense. Or you just need to make sure you put this whole thing in parentheses if you're trying to put it in at once. Because why your calculator messed that, like why it got the wrong answer there was because it thought you, like, you don't put the extra parentheses, it thinks you're dividing by 12 and then multiplying by the other log. I'm pretty sure that's what it's doing. So like I said, you might want to just do one at a time when you divide. Sorry, I just kind of, so if I had more space, I probably would have done that divide by the log, then divide by 12. But I was just trying to skip some steps just because honestly, the space was an issue for me. All right, so keep in mind, one kind of tip is anytime you're solving for a variable that's in your exponent, you're going to have to eventually take logs of both sides. That's one thing to keep in mind. That's why, like in the first problem, we did not have to take logs of both sides because I wasn't solving for a variable that was in the exponent or power. Section 3, we're going to solve for the principal. First off, I just kind of skim. I see we're compounding continuously, so that means we're going to be using that E formula. So if you see compounded continually, like I said, that means you're going to have the Euler's constant or the E. So that's our formula we'll be using. So they tell us our interest rate is 0.031. We want to figure out how much he would need to invest to the nearest $10. So we'll have to pay attention to that. The nearest $10 they want us to round to, of the value to reach 990. That's our A. That's our goal. That's our goal for our final amount. And then obviously 6 years is our time. So they tell us our A. We don't know the principal. Basically, he's trying to figure out how much money he'd have to invest to reach this goal. So the P is what we're trying to find. Keep in mind, remember in this formula, E is not a variable. So it's not like something we need to solve for. Our interest rate is 0.031. And then our time is, sorry, not, we know what that is. So that's 6. Like I said, if you actually have a graphing calculator, when you plug this in, you're going to want to put parentheses around that, most likely. You might get away with it. I'm not 100% sure, but I can try it on mine really quick. But basically what we're going to do is, remember, E is not a variable, so we can figure out what this piece is here. Like we can put this in our calculator. I mean, once we figure out what that part equals, then we can just divide the other side by it to get our P. So let me just write this down. So we have E up to the 0.031 times 6. So we'll just go to our calculator. So remember, to do E, you do second ln, or your natural log. Like I said, you probably want to put a parenthesis when you have like multiple things, or you just want to multiply it together first and then plug it in. 0.031 times 6. It's approximately 1.204. We're rounding to the nearest $10, so like rounding is probably not that big of a deal, but you do want to be careful when you're rounding because, like I said, it could mess you. Like I always get a little bit nervous with these, but I'm just gonna put, oops, put the highlighter, but it's approximately 1.204. I mean, you could round it, you could put more, you could put a little bit less, you'd probably be fine. But then we'll just divide the other side by this and we'll have our final answer. So our answer, 990 divided by 1.204, I'm plugging that in. I got $822.25, but they want us to round to the nearest $10, which is kind of like a weird thing to round to. That's not super common. But the nearest $10, then that would be $820. You know what I mean? So just pay attention to what they want you to round to. But the reason Delta Math might be using these weird rounding things is just because you can, if you round, you can kind of get slightly different answers. So they're probably trying to make you round to bigger quantities just so in case you rounded slightly different in the process, you don't miss the question. Because obviously how Delta Math, it's a computer grade and you can't, Like it doesn't know if you're right or wrong based on like rounding. So that's why they're probably having you round these different amounts would be my guess. But notice in this problem, we weren't solving for a variable in our power. So that's why we didn't have to take the log of both sides or the natural log of both sides. One thing I don't know if it's, I can't remember if I pulled one in our notes, but keep in mind, if you're dealing with this compound interest formula and you're solving for a variable, like, let me just write this really quick. But let's say you had a problem like this. You wouldn't just take the regular log of both sides. Remember, if you have E, you have to take the natural log of both sides if you're dealing with solving this. So that's one thing to keep in mind. If it's the compounded formula, you have to use the natural log. You could actually use the natural log for all of these problems though, because remember, for like this problem up here, when I took the log of both sides, I really could have done the natural log of both sides. Wouldn't matter. It doesn't matter what log you take of both sides unless you have that E. If you have an E, you have to take the natural log. So sorry, I know I'm rambling a little bit, but so then section 4, we're going to solve for an interest rate. Let's see what this one in it says, compounded continuously. So once again, we are using that E formula. So 860, that's how much she's investing. Oops. Ooh, there it is. Okay. 8's going to be our time, assuming it's compounded continuously. What's the interest rate to the nearest 100th? So that's 2 decimal places. Would be required in order for Julia to end up with this amount. So that's our A. Okay, so I think we're actually going to see a problem like I was just kind of talking about. So we'd have 1,190 equals 860 times E up to the 8R, because we don't know what our rate is. We know what the time is. So we want to solve for this R. So the first thing you want to do is divide this 860 out of the way. So 1,190 divided by 860. And like I said, especially because we're trying to get a pretty accurate answer, I'm going to put a few decimal places. It's like 1.3837. I'm going to put 4 places just because I get nervous. You might be okay if you don't put as many, but if you miss an answer, it might literally just be because maybe you round it too much. That's what I fear. So the more decimal places, probably the better, or just keep it in your calculator even. But remember, so to solve for a power with an E equation, you're going to take the natural log of both sides. What happens, remember, a natural log of E, basically what happens is this just cancels out. Like a natural log undoes a base E. So on the right side, we would just have 8R equals this natural log of this 1.3837-ish number. So basically, I have this still, well, you're going to have to type this in your calculator and divide it by 8. So like the natural, let me just write this down. So the natural log of 1.3837 divided by 8. So when you type this in your calculator, though, be really careful. You're going to do the natural log 1.3837. Make sure you close the parentheses, and then divide by 8. If you don't close that parentheses, you're going to get it wrong. And they said round to the nearest 100th. That's 2 decimal places, so that would just be 0.04. So it seems like they're, whoever made these problems or however they made these problems, it seems like they're pretty smart about making them so like you don't get a slightly different answer just based on estimation. So it shouldn't, it looks like it won't be a big problem, but I always get really nervous when it's like a computer program. Like it's, obviously, if I was grading your problem and you were off by like a 10th, I'm gonna know you did the process right, but I don't trust like a Delta Math, like a computer program all the time. Okay, and then the last section you're gonna see in Delta Math is they're gonna give you kind of 2 different cases of people with a bank account. And basically you're just gonna try and figure out how much more money someone made than the other. This is a common type of question you might see that might have you compare different accounts to see who would make more. So in this problem, we have Kylie, and she's compounded annually. So they're using 2 different formulas. If you kind of notice, one, Kylie is compounded annually while Ariana is compounded continuously. So I'm going to kind of do Kylie here, and we'll do Ariana, right? So Kylie, we're using that first formula. So I'm just going to write the formula. So it's and then Ariana, we're going to use this formula. Oops. But so far it's it that they one, if you kind of, I know I'm kind of jumping around the problem, but both of them have the same principle. So I'm going to just start kind of plugging in stuff. So the principal is going to be 2,800 for both of them. They have Kylie has an interest rate of 5.5%. So or 5.5%. But remember, 5.5 divided by 100, if we put that in decimal form, that would be 0. Her interest rate is going to be 0.055. Ariana has an interest rate of 5 3/4. That's 5.75. So that would be her interest rate is going to be 0.0575. And they're both investing for 12 years. And we want to figure out who would have more. So T is going to be 12 for both. Oh, and then sorry, for Kylie, it says it's compounded annually. So remember, annually means once a year. So her N would be 1. So if we start plugging this in, sorry, I'm jumping around a little bit, but A is what we're going to be solving for both of these. So it's not going to be super complicated. We're just going to kind of plug these in, see what we get. But it would be 1 plus 0.055 over 1, because that's your N. And then 1 times T, well, that would just be 12 as the power. For Ariana, it would just be E up to the 0.0575 times 12. Then you're just going to plug these in. So one tip for Kylie, since it simplifies pretty nicely, I mean, this is just going to be 1.055. So that's probably easier to plug in. But for her, it would be 2,800, 1.055 in parentheses up to the 12th. And they want us to round, well, I'm not going to round yet, but when we get our final answer, we're going to round to the nearest dollar. So I'm going to put at least cents for these answers here. So that's what I got for Kylie. For Ariana, 2,800 times E up to 0.057. Oops, put an extra 0. What's that? It's 12. For her, I got 5,582.40. So then they want to know how much more did Ariana make than Kylie invest in. So you would just subtract these totals from each other. Like obviously the 5,500 one first. And they want, so when I subtracted these, like when I subtracted this from this, I got $259.02, but you might have got something slightly different if you rounded or didn't round as much as I did. But they want you to round to the nearest dollar, so it'd be 259. And that is, these are the type of problems you will see.